This is example number 2 on the Essentials AP Problems number 2 worksheet. Basically, to give you an overview of the problem, you're told that you have this line that is tangent to this function in the first quadrant. And basically, we're supposed to figure out the value of k that is going to make that possible. Okay? A couple of things here. You really have to start to make some connections between the calculus that we've learned and the problem. Okay? And sometimes you're not going to have a real good idea of where this is going when you begin the problem. But that's where you've got to start. Okay? So first of all, I know in general, if I have some kind of a curve, and I have a line that's tangent to that curve, I know that I've got to find the point where those two values intersect each other, because they don't intersect at all places. So I need at least an x-coordinate where they intersect. The other thing that I need is I need that slope. And I know that tangent line is going to have the same slope as the derivative at that point on the curve. Okay, so two things, and I'm actually going to start out with that because I think that's really where the calculus comes into play. Number one, I want to find the slope of my tangent line because that's a straight line equation. That's very easy. So if I write this in slope-intercept, form, that's going to be negative 4y equals negative 3x. You can divide both sides by negative 4. I find out that y is equal to 3/4 x, okay? The tangent line has a slope of 3/4. It has a slope of 3/4 at all points, okay? So, if it's going to be tangent to this curve anywhere, that point where it's going to be tangent to it is going to have a slope of, or the curve is going to have a slope of 3/4 at that point, okay? So I just have to figure out where that takes place. Well, okay, so if I'm talking about the slope of a curve at a point, that's the derivative. Okay, so I need to come over here and I need to find the derivative of this, and we need to figure out, where does that derivative work out to be the same as the slope of the tangent line. So the derivative is 3x squared. That's a constant value. Constant value has a derivative of 0. Don't worry about it. Throw it out. K doesn't matter for now, although it comes back into play in a second. So you look at this and you say, now wait a second. I don't see a 3/4 here. Remember, this is all of the possible derivatives at all of the possible points. Okay? So we're not looking for a coefficient here or anything like that. That is the derivative. These are all the different slopes of tangent lines. Okay? But we know that this tangent line has to have a slope of 3/4 coming from that original line slope. So I really need to figure out when is y prime going to work out to be 3/4. And we can divide both sides, so basically set y prime to 3/4. We'll find the x value where this function is going to have a slope of 3/4. That's the idea. And plus, if you remember, I need to know a point where those two lines intersect, or at least I need to know some of that information anyway. So this takes care of several things at the same time. Divide both sides by 3, you end up with 1/4 equals x squared. Remember that they're talking only about the first quadrant, so we only need to look at the positive square root here. Of course, if I take the square root of both sides, I find out that x is equal to 1/2. And you have to be careful, because 1/2 is one of the choices on the worksheet, not one of the answers that we want to use, because they didn't ask me for the x point where those lines intersect at the same slope. They asked me what the k value is going to be. Well, what does this have to do with anything? Remember what I said before. We've got some kind of a curve that hits some kind of a line at a given point. Okay? We now know that this line has a slope of 3/4. And we know that this line has a slope of 3/4 when x is equal to 1/2. Okay? So, at that point, I need to figure out what value of k is going to make this function work out to give me that value up here. Because remember, this line is going to have to pass through the same point as this line over here. Okay? Since I already have the equation for this line over here, I'm going to go ahead and put the x of 1/2 back in up here. Okay, I end up getting 3/2 minus 4y equals 0. I'm going to add 4y to both sides. 3/2 is equal to 4y. divide both sides by 4, we found out that y is equal to 3/8. Okay, so this line over here passes through the point x equals 1/2, y equals 3/8. We have to set it up so this equation also contains that point. Okay, so you can put the point back in there, substitute in 3/8 for y, substitute in 1/2 for the x value, and we have our k here. And what I end up with is basically finding out that 3/8 is equal to 1/8 plus k. What does that mean? Well, that is 1/8. So k has to be 2/8, which of course we know is 1/4. Okay? Not an easy problem at all. But you know that you can find the slope of the line. We know that the slope of the curve at that same point can be found using the derivative. You can use that to find the x-coordinate where that takes place. You can use that x-coordinate then to find the point where that derivative takes place. And then you can put the x and y coordinates back in here to find y. Okay? So again, you just have to move a step at a time, and you have to connect the things that you know to be able to get these things to come together. This is example number 4 from Essentials Worksheet number 2, problem number 4. My second example, but it's problem number 4. We want to find the equation for the tangent line to y equals the arc sine of x over 2 at the origin. Of course, the origin is the point 0, 0, which is actually going to make this pretty easy to write the equation of the line because we're not going to have a y-intercept here. So the big thing here, of course, is if I'm going to write this equation, I need to find the slope of the line at the origin. Okay? How do I find the slope of a curve? I find the derivative. Okay? Now, you may want to write this function in a different form. A lot of you probably learned this as inverse sine of x over 2, might be how you wrote that thing. And if you remember, the derivative of the inverse sine function is 1 over radical 1 minus x squared. And so we just need to follow that pattern over here. So y prime is going to be 1 over, and it's going to be a big radical. It'll be 1 minus that inside function squared. Okay, so it's going to be x over 2 squared times the derivative of the inside function. You've got to remember that derivative of that inside function. That's a 1/2 x. So derivative there is going to be 1/2. You multiply this whole thing by 1/2. All right, what happens here? Well, a little bit of simplifying. Y prime is equal to 1 over radical 1 minus 1/4 x squared. It's all being multiplied by 1/2. So numerator gets multiplied by 1, denominator gets multiplied by 2. I'm going to put the 2 out in front there. Now, we need to find the derivative at this point. We were given the point. We were given the origin point of 0, 0. So that's going to be when x is equal to 0. So I'll substitute that in here. That's great. This thing goes away. Y prime is going to equal 1 over, it's going to be 2 times radical, that's 1 minus 0 when we work this thing out, which of course means that y prime is really just going to equal 1/2. Okay? Now, if you go back to the original problem gives you several functions there. And of course, you can actually just write, we can go ahead and write the equation of this line. Normally it would be y equals mx plus b form. We know that the slope here needs to be 1/2. Okay, if it's going to pass through the origin, the y-intercept is of course going to be 0. And so one version of that formula is y equals 1/2 x. If you take a look at the answer sheet, that's not one of the choices. I think you can probably see the equation at this point, but you can also move everything over to the same side. I'm going to double everything here. That means that 2y is going to equal x. I'm going to subtract x from both sides, and let's see which one matches. Actually, I'm going to move the 2y over here, and so I'm going to get x minus 2y is equal to 0. And if you check, they have it written with the 2 sides flipped there. But anyway, x minus 2y is going to end up being the function, okay? It's going to have a slope of 1/2, which matches the slope of this function at the origin. So Hopefully that helps out. Now I'm looking at problem number 7 from essential sheet number 2. We want to find the equation of a curve that intersects every curve of the family y equals 1 over x plus k at right angles. Okay, so basically if we're going to have two curves intersecting at right angles, what that really means is the slopes at the points of intersection are going to be opposite reciprocals or negative reciprocals. Those slopes at those points are going to take place at the derivative value. And so that's what we need to look at here. So basically I want opposite reciprocal derivatives. Okay, and again, at any given value of x, we can see that those two things would match up and have the opposite reciprocal slopes where those curves hit each other at that x coordinate. So I can come in here, I know that y prime, I'm going to write the original function, actually I'm going to rewrite the original function here first. I'm going to write that as x to the negative 1 plus k. The derivative here then is going to be negative x to the negative 2. Derivative of a constant is 0, and just for the heck of it, I'm going to write that as negative 1 over x squared. And here's what's so important. What's so important here is, if this is a function representing the slope, and I want a function that's hitting this thing at a perpendicular, any possible slope for that function also needs to be the opposite reciprocal or the negative reciprocal of this function. Okay, so basically what I'm looking for here then is a function that has y prime being the opposite reciprocal, positive x over 2. Okay, now if you take a look at the answer sheet, you have a couple different choices here, and you'll notice that choice D does exactly that. D gives you the function y equals 1/3 x cubed. Okay, take a look at the derivative function. When I take the derivative of this, when I find y prime, 3 times 1/3 is 1. I drop my power by 1, and you have opposite reciprocal derivative functions, which means for any value of x where these functions are defined, their intersection points are going to happen in perpendiculars. So again, you've got to follow those keywords, and you've got to look really closely. But really, all you have to know here is slope of a curve takes place basically at the derivative value, and perpendicular lines or perpendicular slopes have opposite reciprocal slopes. And if you've got those two facts, this whole thing comes together very nicely. So connections, connections, connections. Very, very important working on AP problems. This is problem number 9 from Essentials sheet number 2, and it sounds terrible, okay? It really, really sounds awful. They give you a derivative here of a function, and they tell you that that's g of x. And by the way, notationally, another way of writing the derivative of f of x is to say that's f prime of x. Okay, so keep that in mind. F prime of x is the same thing as g of x. Those two things are going to be interchangeable anytime we have those values come up. And that's something you want to keep in mind. Okay, now if I take the derivative of this thing, I get this. Okay, well, the derivative of this, which is the same thing as this, is really the second derivative of f. Okay, again, may be important, may not be. Okay, other things I notice here. Notation here kind of looks like the derivative. You notice that they have those 2's there. That's a second derivative. Okay, so what they're really asking me to find here is f double prime of x cubed. Okay, and in fact you may even want to put that in there. Now we don't exactly know what that means, but you know, it's a starting point. Here's the other thing that comes into play. You say, well, you know, can't I just use that fact and then use that fact and aren't I done? There's one other thing that is hugely important here, and if you miss this, you miss the whole point of this problem. Notice that's the derivative of x, okay? There's a tendency for people to say, oh, okay, so that's just going to be g of this value here, and then it looks like that value gets squared there, and you say, well, it's probably going to be g of x to the 6th or something like that. And that's the trap they want you to fall into. Okay, there's a little bit more going on than that. This is not just a question asking you if you understand second derivative notation, which almost is what this thing looks like, okay? Here's the key. This thing right here is an inside function. If you have an inside function, the chain rule applies even if you don't have the original function, okay? You can still apply functional notation, okay? Let me give you an example of this. It has nothing to do with the original functions they gave you. But let's say that they give you a function, f of x, and you have an inside function that is a g of x. You know what? Yeah, that'll work fine. Okay? If you want to take the derivative of this thing, it's actually going to be the derivative of the original function with the same inside function times the derivative of the inside function. Okay? Now, we're used to doing this where you actually find the derivative. Here I can only do it notationally, but it's the same idea. Okay? And AP is going to push you to see, can you do something with the actual values? But also, can you do something from an abstract standpoint? Because that's going to make a difference here. Okay? So again, this does not directly have anything to do with this, but there will be a connection. So let's try this, okay? So I need to take the first derivative of this thing, okay? Well, first derivative of that thing is going to end up being, we'll call that f prime of the inside function. Inside function does not change, times the derivative of the inside function, okay? You do have to apply the chain rule here, even though we don't have the original functions, okay? Now, from a notation standpoint, we know that f prime is the same thing as g of x, okay? So I'm going to replace this thing here with the g function, just because it gets us a little bit closer to the answer. Of course, this we're completely fine. Now, I don't want the first derivative, I want the second derivative. Notice also, there is a product here. You're going to have to apply the product rule. All right, so product rule says derivative of the first function times the second, plus the derivative of the second times the first gives you your derivative, okay? Be careful when you take the derivative of this in the product rule. And of course, product rule, derivative of u times v is u prime v plus uv prime, if you want to look at it that way. Derivative of gx cubed has an inside function. So that's going to be g prime of the same thing times the derivative of the inside function, which gives you a 3x squared, which I'm going to write out in front. Okay? So this thing here is just the derivative of that. Derivative of the first times the second, plus the derivative of the second, which is going to be 6x, times the first, which is g of x cubed. Okay? Now, we've got some things here that need to be replaced. If you come back up here and you look at this, the derivative of g of x, which we could also think not only being f double prime, it's also g prime. That's this thing right here. Notice, derivative of g of x is f of x squared. That inside function has to be squared. Okay, so I'm going to have a 3x squared. I'm going to replace this, g prime, derivative of g, with f of the inside function squared. A times 3x squared, and then I have plus 6x times g of x cubed here. Okay, a little bit of simplifying. I end up 3x squared times 3x squared. Be careful with your exponents. That's 9x to the 4th times f of x to the 6th plus 6x times g of x cubed. And let me take a look here and see if that shows up as one of the choices on my sheet. That is choice D on my sheet. Okay, so again, they want to know, do you have an abstract understanding of the chain rule? And do you have an abstract understanding of the product rule? And that's what this shows. This is from the Essentials number 2 worksheet. This is problem number 11, final one I'm going to look at today. Gives me a function again, it's written in general terms. This is not the actual specific function, but just written in functional notation. F squared of x minus g squared of x. They tell me a couple facts. They tell me what f prime and g prime is. Okay? Think about what's happening here. If I have a function like sine squared of x, just to look at this with specifics, that's really sine of x quantity squared, okay? If you're going to do this, then, if you're going to take the derivative, to take the derivative of this thing, I'm going to need to apply the power rule. So that's going to be 2 times the sine of x, drop the power by 1, and then I multiply by the derivative of the inside function, okay? Same kind of thing is going to apply here. We just have to do it in an abstract sense instead of doing it in a specific sense. Okay, so this is really the same thing as f of x quantity squared. 2 times the leading coefficient of 1 is 2. Inside function stays f of x. Power drops by 1 to 1. We multiply by the derivative of the inside function, which is f prime of x. Okay? Now I'm going to subtract the second part here, and basically the same thing's going to happen. That's going to be 2 g of x to the first power times the derivative of the inside function, which, of course, the inside function here, because that's really g of x squared, it's going to look something kind of like that. And then if we look back, we can see here that f prime is the same thing as negative g of x. So I can replace that with negative g of x. We see that g prime is f of x. And so I should be able to do a little replacing here. Let's see what we get. Actually, I want to look at my answers here on my sheet as well. Do they factor that out? Now let's just leave it like it is, actually. Okay, so what am I going to get here? I'm going to get a negative 2 f of x, g of x, minus 2, I'm going to change the order here, commutative property, f of x, g of x. I thought, hey, I can factor out a GCF and all of that, and then I realized, oh, wait a second. I literally have a value, and then I'm subtracting that same value. And it looks like, as a result, I'm going to get negative 4 f of x, g of x, right? Because I have 2 of these minus 2 of those. Negative 2 minus 2 is negative 4, and that appears to be choice number C on number 11. Okay? So you got to be careful with your signs there, because we get a negative there and a negative there. We don't have a cancellation. Very easy to think that that answer is going to be 0 if you don't watch your signs. That's all there is to it.